Hello, everyone. My name is Ryan Boylan. I'm the Research and Monitoring Coordinator with the Palouse Conservation District. And I'm here to talk to you today about a soil health data communication education tool that we've developed for the Inland Pacific Northwest. I just also want to acknowledge the other folks that have helped contribute to this, which is Nick Harris and Zach Carter, who both work at the Palouse Conservation District, and Tabitha Brown, who's a colleague of ours who works with farmer in the region. The take-home message for our talk, or kind of the general theme, I guess, is that the Palouse Conservation District has been working to develop an interactive soil health data portal with the goal of creating a platform for producers to share data and learn from one another in their on-farm trials. Before I get into the presentation, I just want to give you a quick overview. I'll talk about the background of where the Palouse is and where we do our work. Talk very briefly about a big conservation effort that's happening, and then how that has led into us developing the soil health data portal. All right, with that, I'll show you a picture of the Palouse River watershed. This is the Palouse River watershed. It's located in eastern Washington and parts of northern Idaho. It's just over 2 million acres, and 67% of that is in agricultural land. In the heart of the Palouse River watershed, right in the center, is Whitman County. And as you drive into Whitman County, what you see is a road sign like this that says the nation's leading wheat producing county. Whitman County and the Palouse in general has some of the highest wheat yields in our country, which means lots of agriculture. All the water from the Palouse River watershed drains over Palouse Falls, which is Washington State waterfall, into the Snake River. And the Snake River is critically endangered habitat for fall and spring Chinook salmon. So all the work that we do up here goes downstream and helps to protect salmon as well. As I mentioned, the Palouse has some of the nation's highest wheat yields, and all that comes down to the soil. So we have these really deep wind-blown loess soils that have been generating high wheat yields for a long time. Starting in the 1890s, folks came and started farming the land, and you can kind of see the progression here from horse-drawn equipment. In the early years and like up to the 1970s, there was a lot of issues with soil erosion. And they estimated that 3/4 of a ton of soil was lost for each bushel of wheat that was produced. And annual average soil erosion rates range from 10 to 80 tons per acre per year. Since the 1970s, the advances in farming practices and technologies such as no-till drills and direct seeding and the implementation of conservation practices have reduced these erosion rates to 5 tons per acre per year, which is great. We've almost cut that in half, or by 400% in some cases. But if you think about 5 tons per acre per year and roughly 1.7 million acres that are in agriculture, that's still a whole heck of a lot of erosion that we see entering our water bodies. So in 2015, this group of 19 partners came together and we wrote a grant to the Natural Resource Conservation Service, and we received it, and the Palouse River Watershed Regional Conservation Partnership Program was formed. The whole goal of this program was to improve water quality, soil health, and wildlife habitat in the Palouse River watershed, and the main objectives were to install a whole lot of conservation practices, including 45,000 acres of conservation tillage, 450 acres of riparian buffers, and 530 acres of conservation easements. So since 2015, we've accomplished all of these goals, which is great. So we pat ourselves on the back for that. And then we've also got an extension. So over the next 5 years, we will be implementing just as many of these. The reason I talk about the program and the big effort, the partnership that we formed, is because that's enabled us to work with a lot of producers in the area. And I was hired in the start of that grant to set up our research and monitoring program. And one of the sections of my program is the soil health program. And so I work with a lot of farmers all over the Palouse River watershed. And our goal initially was to identify regionally specific trends and soil health indicators over a range of management practices. And some things that have kind of come out that since that original goal was stated is a lot of the work that we do now is to support on-farm research trials for folks that want to try things. One of my favorite parts of my job is when somebody comes to me with an idea and they ask if I can help them assess that idea, or at least soil sample out there to see if it's making a difference. And then what I'm going to talk about today is facilitating peer-to-peer learning through a soil health data portal. I just want to touch briefly on the management practices that we're addressing or that I'm talking about. I should have said this in the beginning, but all of the agriculture here is dryland ag. And historically, there was a lot of tillage, which led to all that erosion. So we're still assessing some of that conventional tillage. There's mulch till or conservation till practices that we're assessing. True no-till practices, no-till practices that have started to integrate cover crops. Then there's interseeded cover crops with cash crops. There's folks are starting to integrate livestock and grazing those cover crops. We're assessing those. We also have a couple, or a restored prairie site, a native prairie site. We've sampled on CRP fields and then also in a couple of riparian areas. Here's just a quick map of our study locations. The gradient in colors there just indicate the farming zone. So as you move from west to east on the Palouse, you go from a grain fallow sort of system into an annual cropping system. And the typical crop rotations in the annual cropping system would be winter wheat, followed by a spring grain, followed by a legume. So within our study, we have 17 farms and 54 fields that we've assessed since 2016. We collect samples in the fall and the spring. Originally, we were sampling at 4 depths, 0 to 6 inches, 6 to 12, 12 to 24, 24 to 36. But currently, we've scaled back on that and are just doing 0 to 6 and 6 to 12, the two. It saves money and time for all of us that are out there, and we're assessing a lot of fields. And so within each field, we randomly select sampling locations which are representative of the topography and then also of the different soil types that are out there. So for each field, we composite the samples, and there could be up to 15 stabs taken per field, and then those are put together to make one sample and sent to the lab. For the data analysis, we're essentially sending these samples to 3 separate labs. The first one is the Midwest Laboratories, and they're just kind of doing our traditional fertility tests. The second one is Woods End Lab, and they're doing kind of our soil health overview. And then the third one is Earth Fort, and they're doing soil biology for us. So all this data is stored on our PCD server, and then each year we share it with participating farmers. And so now I'll just jump into showing you what the Soil Health Data Portal is. But before I do that, I just want to say, one of the reasons that this was created was I was spending a lot of time each spring and fall just packaging all the data that we were getting back from the labs and sending them to people, or to the participating farmers. And one of my coworkers, Nick Harris, who was mentioned in the beginning, we had the idea of putting together a little application that could display the data for people, because getting 7 to 10 PDFs in the mail or via email can be sort of hard to synthesize. So we were like, oh, we'll just do this. It'll save us time because we can just put the data into this application and then they can view it. And then they can also download it from there. So one of the reasons this happened was maybe because we were getting lazy or trying to be more efficient. So yeah, this is what the Soil Health Data Portal looks like. This is just a landing page. We have a little video tutorial about how to work the tool itself. And then each producer can click on that blue box where it says click here to get started, and they all get a producer ID that's emailed to them. They fill in that producer, they type in the producer ID and then click proceed to view your data. And this is kind of what it looks like once they get in there. You can see on the left-hand side here where it says data inputs, producers can select their specific field. It depends on the person, but there could be up to 5 fields that we're sampling for these folks. They can select the type of analysis, and we've broken that down by biological, chemical, soil health, and physical. And then they can select their data grouping desired parameter in the test. And this is just kind of a close-up of the figures that pop up when they go in there. There's essentially 4 things going on here, and I know it seems like a lot, but I'll just walk through them really quick. So there's a map in that top left-hand corner of the fields that we've been sampling. That top figure here just shows seasonal averages by depth of the specific parameter. So for this instance, it's organic matter. And you can see it's color-coded by year and season and by depth here. The second figure is a management comparison. Oops, sorry about that, is a management comparison. And these are just box plots of all the different management practices that we've been sampling. And you can see those red circles there are indicative of the management practices that this particular producer has on their farm, has on his farm. So you can kind of see how the samples that we're collecting on their place stacks up against or across multiple management systems or management practices. And then the final, I'm just going to move my video real quick. The final figure that we have here is a regional comparison. So this is a concentration or percentage. In this case, it should be percentage organic matter by depth. And then each one of these different colored bars represents a farm average here in green, a field average, so for this particular field, RBFB that we've selected, and a regional average. And this is all based on the management practice that they've indicated to us that they're using in that field. Another thing we've been working on, because we can just, for this particular application, you can just show one field. We have this field comparison. So an individual could select to look at organic matter across all their fields, and that's what this plot shows. It's for the 6 fields that we've sampled out there. They can just see how that's changed over time and by field. So in this case, you can see that RBFD and RBFE have lower organic matter concentrations than the other 4 fields that we sample. Yeah, and this is just another tab that's at the top of that landing page once they enter their ID. So yeah, that's a brief overview. We've really just gotten started doing this. And the next steps would just be to continue to develop the tool. There's still some bugs that we're working out. And you could probably see some red text in that previous slide. And that's just a kink that we're still trying to work through. We're going to continue to work with producers to make the portal more user-friendly. I've presented this to 3 of the folks that we work with. And the very first iteration of this, they were like, I don't know how to use this. You have to walk me through it. So that kind of prompted us to have a video, and then I've walked them through it, and some of them have found it useful. We also want to hold a workshop with several of the producers that we're working with to see what we can all learn from the data that we're collecting. So have maybe sometime in the first half of that day just to show the tool and get people familiar with how to use it, and then get folks talking about how this information is useful for them and then what they've been learning from the trials that they've been running on their farms. And then the final thing that we're going to be working on is, yeah, we've been collecting data for 3.5 years now and analyzing that data to try and achieve that initial goal of identifying regional trends and soil health indicators. And with that, I would be really happy to take any questions. I have my contact information down in the bottom right-hand corner there, and then Nick Harris, who's also worked on the application with me. I should also probably thank the folks that support all this work. It's the Washington State Department of Ecology, Washington State Conservation Commission, and the Natural Resource Conservation Service. And with that, I'll go offline and answer any questions.